How's it, grade 12s? So what we're going to go on to now is parallel line theorem. We're dealing with slides 22 to 25 from the PowerPoint proportionality. Okay, so what does parallel line theorem say? If you're given a triangle like this, and you've got a line parallel to one side of the triangle, okay? So we are given that PQ is parallel to BC. What can we say from this? Well, we are going to get some proportions coming out of this. We know that we're going to get AP over PB will be equal to AQ over QC. As soon as we do this, the reason for this is line parallel one side triangle. So you know with geometry, if you give a statement, you must give a reason. That is your reason that we're going to be using from now on. Okay. To recap, line parallel to one side of the triangle, you're going to get proportions coming out, just like that. Okay. So if we have a look at example 1. All right, so we've got our main triangle here, this ADG triangle, and then we have a few parallel lines going on there. Okay, so they're asking us BC to CD. We've got BC to CD. Okay, so we can ignore that part and just have a look here. So BC to CD will be FE to ED. So this will be equal to FE to ED. And your reason, line parallel one side of the triangle. I'm not going to write that just yet because this is just showing you how it works. The next example, I will start writing the reasons. Okay. If we have a look here now, they're asking us BD to CD will be equal to, so again, we can ignore that. We're just working with this DBF triangle. So let's go through it again. BD will relate to FD over CD ED. All right. Now, we spoke about this before. A ratio you can write as a fraction, just like what we had with these two over here. So this is actually saying AB over BD. Okay. But because I gave it to us in this form, I'm going to give the answer in that form. So we've got AB, that. So we know that's going to be, that little section will correspond to this little section. So it's going to be AB, GF, and then BD is that whole side there. Come down, it's going to be that whole side there, FD. Okay, reason, line parallel one side of the triangle. Cool. Example 2. Okay, so I've just drawn it out here. If you have a look in your books, they've given you a whole bunch of information, but we can write that down as we go along. So it says that DE is parallel to BC, so that's been marked there. It then says that AB is 28 millimeters. So we know that this entire length here is 28 millimeters long. Okay. They then told us that AE to EC is in the ratio 4 to 3. Now, grade 12s, this is not a length. This is not saying 4 millimeters and 3 millimeters. It is a ratio of 4 parts to 3 parts, and we have a total proportion length of 7 parts. Okay, it is not a length. So it goes on to say we need to calculate the length BD. So we want to figure out how long is that in terms of millimeters. Okay, so the first thing I'm going to say is that we know that AE to EC is equal to 4 to 3. Okay, that was given to us. So the next thing I'm going to say is I'm going to find out what this side is in proportion. Okay, so this was AE, EC, so we're going to get AD, DB. So we know that AD to DB will also be equal to this ratio. Okay, why have I said that? Line, parallel, one side triangle. Okay, this to this equals that to that, and that's what we've got there. So now I'm interested in this dB side. Okay, and we also now know that this is in the ratio 3 to 4 from here. Okay, so this little dB side there, he's going to be equal to 3 parts out of 7 parts, because if this is 3 and that's 4, a total proportion length of 7. And we're going to multiply that by 28, because it's 3 parts out of 7 parts gives us this total length of 28. And then you can calculate what that is. It will give you 12 millimeters. Okay. On to example 3. Okay, so this is where it starts getting a little bit more hectic. Okay, so just to read what they've said here, they've said that D and E are points on the sides of AB, BC, of triangle ABC, such that AD to DB is in the ratio 2 to 3. So we have here 2 parts to 3 parts. Okay, that's over there. They've also told us, they've gone on to say, and BE is equal to 4 over 3 EC. Now what I'm going to do with this one is I'm just going to manipulate it so I can get it into a ratio form like this. So if I divide both sides by EC, I will get BE over EC is equal to 4 to 3. Okay, so if we look for BE, BE is over here. So BE is 4 and EC is 3. So that's in the ratio 4 to 3. Okay. It goes on to say if DK is parallel to AE and AE and CD intersect in P, we have to find the value of CP, this one, to PD, CP to CD. All right, so let's go for this grade 12. So first of all, we know that AD to DB is in the ratio 2 to 3. So AD to DB is equal to 2 to 3. And we know this because it was given. And I've just marked it on the diagram there. That means that, therefore, AD to AB. So AD to AB will be equal to 2 parts, because that's our AD, And then AB will be the 2 and the 3 parts together, which gives us 5. So we have that ratio of 2 to 5. Now that means we can link it to the other side. So that means that KE to BE will also be equal to 2 to 5. So we have this KE to BE will be 2 parts to 5. So this is 2 parts, and then this whole part here is 5 parts. Okay, carrying on. Now, I'm going to use this bit of information here. They've told us that, that we have BE to EC is equal to 4 to 3. So BE to EC is equal to 4 parts to 3, and that was given. Grade 12, so I've forgotten to put up here my reason for this. I apologize. This was line parallel one side triangle. And we can just say that DK parallel AE. Okay, apologies for that. Right, so this now means, once we've got this, that means that KE to EB is 2 to 5. So we have KE to EB is equal to 2 parts to 5. Okay, KE to EB, 2 parts to 5. But we know what EB is. EB is 4 parts. Okay. So that means that we can get KE on its own with its own ratio, because you can see we've got some conflicting proportions going on here, where this is 4 parts to 3, and then we have 2 parts to 5. So what is actually KE on its own? Okay. And that is why I'm going down this route, just to get KE on its own as its own little proportion. So if I multiply up here, I can get KE is equal to 8 to 5. Okay. Now, grade 12, so I'd just like to mention here that what I should have done here is I should have added a K here. All right. And then that means I would have got a K over here. All that K is, it's a constant of proportionality, because I'm comparing 2 different proportions going on here. Okay. So I said KE to BE. Now we know that BE is 4 parts, but we also know that it's 5 parts. And that is where I have to add in this K for constant of proportionality. But for this, I'm not going to put in the K because it gets a little bit more complex then. So leave the K out. All right. So now I know that KE is 8 over 5. What I can do now is I can now say CE to EK will be CP to PD, which is what we wanted. Okay. So we now know, therefore, CE to KE is equal to 3 parts to 8 over 5 parts. So we have 3 parts to 8 over 5 parts. And I'm just going to simplify this by multiplying up by 5. So we get 15 to 8, all right, for CE KE. Now that means, therefore, CE to KE will be CP to PD. So we can get now CP to PD will be equal to whatever this ratio was here, which is 15 to 8. And the reason why I said this, line parallel one side triangle and it was dk parallel PE. All right, so a little bit hectic, I know, but just run through it and make sure that you understand what I did over here. I'm just going to brush over why I did this again. Is because we have two different ratios going on here for KE. All right, and I wanted to find KE on its own. Don't worry about the K, I just mentioned it so you know that you're aware of it. Okay, right, grade 12s, I would like you to do exercise 3 for me, please. Thank you.